Ladies and gentlemen, thank you for joining today. This is your humble host Nino, inviting you to explore with me today the marvels of days gone by. AUX or AUX, Apple's Unix experiment from the 1980s. Let us delve into that, and as we do, permit me just one word of advice. Pick either text edit or X-edit, but not teach text. And now, enjoy. Now, I am of course aware, ladies and gentlemen, that many of you know that what we nowadays call macOS or macOS 10 or OS 10, whatever your preference might be, is by far not Apple's first foray into the Unix world, but by all accounts, at least its third major one. If you decide to count also its famous predecessor, Next Step, a thing of beauty, the merger of Art Deco and film noir, a system that looks as if pearls have been cast into black iron. A very elegant affair. And yet before that there was another system known as AUX that was born in the 1980s out of an effort to somehow merge the stability of an underlying Unix System 5 to the beauty and intuitivity of the Macintosh graphical user interface. And I wanted to try that system for years, until finally I came across an application called AUXrunner, available here on Mendelssohn.org. Quite a piggy at somewhat over 7 GB, but that does give you a standalone Qemu system that is running Apple's AUX or AUX without any further thing of you to do. You just start it and enjoy it. Or perhaps one thing to do. This Xatar thing that you need to change the attributes of the application for it to start, that unfortunately is true. If you don't do that, it will just briefly twitch and die without working. And so I got that, and this is what I want to show you today. And perhaps I'll have to admit already early on that I understand why AUX wasn't that successful. So let's perhaps satisfy our thirst and quench our curiosity a little bit by showing what that system looks like when it boots. And then let us explore some things concerning it that might not be that impressive. See, while modern macOS is merging at least somewhat renowned elements of the Macintosh UI to an underlying Unix system cleanly, AUX is doing the same in a rather Frankensteinish fashion. And I don't mean, beautifully Frankensteinish, such as Linux or BSD. I mean rather uglily stacked together Frankensteinish, like DOS and OS2 or something of that nature. You see, the system has booted, we see our clean desktop, but already what makes us an impression is that we're somehow having two disks, something called Macintosh HD and something called /. Oh great, that's super intuitive and doesn't look weird at all. We know, of course, that's the top of a Unix system, but it's not exactly beautiful, right? And why would you have the top of the root file system? If you click on the little apple, you're seeing a couple of perhaps more familiar Apple programs, including this really weird calculator that seems to remember, even across reboots, what you last computed with it. So 4 times 2 is 8. I'm closing it. I'm going to the calculator and hey, once upon a time, somebody computed how much is 4 times 2. I don't know why it does it. It does it though. And somehow I love it. And you're thinking, okay, I'm in the Macintosh world. I tried my calculator. Let me try my text editor. Where would that be on the Macintosh HD, right? There should be some notepad equivalent. And then you're having AUX startup. Likely that's not it. Sounds like some Unix startup thingy, and indeed it is. It doesn't work. Launch doesn't launch a thing. And then you're thinking, let's look into the folders. What about bin? Bin is ugly and showing you all sorts of Unix programs, but if you decide to run any of them, they don't work. Why are they there? Nobody knows, but you have a whole folder full of them that is directly smeared into the face of the user the moment he opens the Macintosh HD folder. Then you're going to the system folder and you're thinking, that then finally must be my System 7 thing that has been sewn together with the Unix system. Apple menu items, that is where the calculator and the notepad live. No, they do not. You're getting some chooser, and the chooser is letting you choose a printer. So it's not called printers, it's called chooser. And then you're having the control panels, which is the same thing as you're seeing here. Somehow you're having it in a separate folder. I mean, in case you want to rather reach it from the folder, I assume. The clipboard, great, so you know what you copied. The control panels, of which some work, such as the monitors, and you can change the resolution and the colors a little bit, and others don't, such as numbers, where it just tells you it cannot be used with this Macintosh, but somehow it is still there. You're having extensions that are no extensions, but that are printers. Chooser, extensions, whatever you call it, it's certainly printers. A finder that doesn't find because it doesn't work. You're having fonts, but actually you don't. You're having a system enabler, which is unable. And you're having startup items, which is just a Unix startup that doesn't work. Finally, you're having a folder called system that merely contains a keyboard layout. Awesome. Why am I seeing such a Macintosh HD if that is all it's going to contain? Where is my Macintosh stuff, my System 7 stuff? Tired of it, you decide to explore the Unix disk, which is not showing you some home directory of any nature. It is throwing you straight at the root. Now, that is the installation we are getting in this system. Maybe it would show you your home directory, because here maybe simply the root home directory hasn't been set. But anyway, that is where we straight jump to ugliness. But not only, there is something relevant in this ugliness that you wouldn't see if you would be anywhere below Unix root, and that is the applications folder. Haha. And the applications folder is containing System 7 applications. There you see something called text editor, and you're thinking, hey, at least that. Trust me, you're going to love it. This one in particular is the good one, for it allows you to choose the font. You could go for Courier, which is really ugly. You could go for whatever you want, but essentially it works just like Windows Notepad. It's one font for everything. Now you might be thinking, can it get worse? Oh yes, it can. Because otherwise you're just having teach text, the famous, most primitive graphical text editor ever. For teach text does not let you change the font. You do have something called page setup, but it is really just about the paper size. Even the options are just showing you some other nonsense, but you're not actually getting to choose the font. Now you may think, my God, it doesn't get worse than teach text. But I assure you it does. For if you were to decide to use the famous Unix system, then the only two text editors that are available to you there are famous VI, and I'm not speaking of Vim, I really mean VI, and Ed, in case you think that VI is too bad. It always gets worse with Unix. Now you think, cool, I want to try one of these Unix things. I want to run Unix. Of course, that will not work, but why not try, right? And then we're having bin. Then you're having again such a list of programs which don't work. At least that's what you think. And then you double click on who, and it does work this time. It just asks you a little bit something and then throws you into a command shell. And now, take note of this fact, which, like in an adventure game, will be important later. We just opened the command shell for the very first time. That will make life a lot more difficult later on. Just bear with me for a second. Okay, we saw who, then we're having weirdo commands like vax. In order to determine whether you are running on a VAX 11750 or a VAX 11780, has a Macintosh ever run on a VAX? Why do we even have this command? So, okay, you close the command shell, a grave mistake, you will see in a second, and you think, okay, if I have to explore it from here, I might as well explore it, from elsewhere. What is this folder Mac? I had not noticed this before. Is there anything? Oh! I found teach text. I can't believe it in the text editor. They are all available. Oh, that's lovely. So, very cool. Finally, we solved the mystery of where these things reside. They reside in the Mac folder in the bin subdirectory. And then you're having something called macx, which I assume is the X11 environment. I would be very surprised if that works, but I really have to try it. Did it start? Does it work? For normally it didn't. If I have now started the X11 server, that would be a great achievement, ladies and gentlemen. And we should immediately try that by opening the command shell, which is nowhere, right? I told you, pay attention, we closed it. We just did open the command shell, but it doesn't actually open in a window. Now we need to go to File and say New, and only then will we get a command shell window. Not the most intuitive thing, right? So I'm closing this again. I'm quitting it. I'm going again, opening the command shell, and this time it did it because I quit it. Okay, so depending on was it completely quit or not, you'll see a window or not. I hate that. Anyway, do we have Xcalc? We saw the Macintosh calculator. How about Xcalc? Xcalc now works. If you do not start macx, which I didn't know how to do just a moment ago, then you will not see that. But that should open our world to yet another calculator. By the way, don't underestimate the X11 calculator because it can compute you the factorial of 100. I would be very surprised, but I'm not going to do it manually if the macOS calculator could do such a thing. So that's a better calculator, even if it looks more primitive. But that should give us one more thing. It should give us Xedit, the X11 text editor, which, as primitive as it is, oh, it is working indeed. So I can write in the old X text editor Xedit. So thereby you have one further text editor. That is, however, certainly lovely because that one should by default give you new line endings rather than carriage return line endings. I assume that is what the macOS one is going to give you. Didn't check though. Good to know. We have Xedit and we have also completely pointless but funny stuff like Xeyes, a program that should show you always where your mouse cursor is right now on the screen. For a small monitor, unimportant. For a large one, sometimes nice to know. Okay, enough fooling. Boy, I love that I have X11 or Mac X or whatever it's called, or X10 or whatever it may be, but I have that. Do I have the X file manager? Now I'm getting greedy, huh? Which size? Let's see what X programs we have, because I was not sure that we do at all. CD user bin X11 and show me what you got. So the command shell. Would it be in any way different if I start an X term? I mean, it looks different and uglier. Very interesting. Very good. So I can start an X term and it is different from the from that command window. I'll just go up here and see whether there is anything recognizable. TWM. No way I can start the TWM window manager. I'm quite sure that if I do, something terrible will happen, because I can't have two graphical user interfaces at the same time, right? X clock might be working. Yes. Ah, very good. And now let's do the nonsensical thing, TWM. It should complain. Ah, couldn't find any unmanaged screens. Excellent. So this is something you can play around with a little bit more. But playing around, you might ask yourself, well, what else can you play around? What else can you do? Let's start for that reason a new command shell. Where are you? At the top of the file system. You're not at home in root, which does exist. And I have even populated it quite a bit. Let me remove something though, because this is part of the show later on. But you're not by default there. All right. Can you go anywhere from here? And fortunately, you can. If you want to ping 1111, that is just going to work nicely. So you do have network connectivity from the AUXrunner app. You also have telnet, which is going to be crucial, as it is going to be part of the easiest way of transferring files ever, without fiddling with FTP, the file transfer protocol as suggested by numerous other sites. Okay, so you're having some form of gate to the outer world, and now the question is just, how do we get anything from the outer world into the AUX system? And to that end, permit me to get out of this full screen display and return to the browser in order to show you a very important website that no longer exists. You get out of Qemu, by the way, via Ctrl-Alt-G, and you toggle full screen via Ctrl-Alt-F. And the important website, which no longer exists, is called Jagubox. That was apparently a machine created by some Mr. Jagielski, or of such similar name, who was working for NASA once upon a time, and he collected a number of programs that work under AUX. And if you try to do anything by yourself, you will very quickly crash against two difficulties. First of all, there are barely any programs preserved from the 1980s. Secondly, your Apple Unix box contains a C compiler, but it is Kernighan and Ritchie C. So K and R C, and your function definitions are all different, and most modern things cannot be compiled. So it will be very hard for you to find anything, but if you find a mirror of the Yago box, such as here on FTP mirror, but there exist a few more, look for Yago box, then you can find here a list of folders which this gentleman created that give you a little bit more of a chance to manage that system. Of particular interest will be the GNU stuff. The GNU is containing the GCC compiler. Now I had difficulties with the 7.0 7.2 version. And interestingly, I noticed that there are two of them, only differentiated by a dot and a dash. I don't know which one was the one I was having issue with, but the one which certainly did work was the 2.6.3 version 2.1. So if you want to compile something with GCC in a modern ANSI C compiler, this would be the one you want. Also, if you do not want to use teach text or text edit or Xedit or VI or ed, you do have a couple of options by now if we think of it. But something more intuitive, you might go here on the utilities, and there you'll find Pine. Pine, the email program set, Pine that contains Pico. Pico being the grandmother of Nano, the famously easy text editor, but you have other things here too, such as Kermit, gzip, if you want, because if you get tar.gz files, AUX cannot naturally disconnect them. And that way you can get Unix programs into your box, some of them precompiled, some of them to compile yourself. I shall get into the exact methods of doing so in a moment. You might also think, hey, why not get something Macintoshy? I'll tell you why. Because it is absurdly difficult. Now, maybe this is just me not knowing how to do it. Maybe it is very simple. Maybe someone will tell me, Nino, you just needed to this and that, and everything is just perfectly fine. But the way I saw it, there seems to be some weirdness concerning the Macintosh file system, something called resource forks. Somehow files are having components which normal Unix file systems do not understand. And then you're having compressed formats, in particular these first two ones, HQX, and more importantly, even SIT for stuff it. It's pure chaos. It's nothing like the zip or tar.gz you have seen in the DOS, Windows, even Unix world. It is a chaos of its own nature, and apparently the way to go along would be to install stuffit over virtual media. But that I regard as cheating, for I told you we are having this very lovely AUXrunner app, and I am sticking to it. I don't want to bore into the guts of Qemu in order to mount virtual media. I want to have something that works nicely and easily, and I see no nice way of doing that, so I'm going to stick to Unix thingies. Now, let's say that you did get GCC and you would like to have it. So here I'm having the GCC 2.6.3 version 2 bin file. I'm going to copy that actually. I would like to have this C compiler into that Unix box, wherever it's now hiding behind all these windows. God knows where I placed it. Yes, here it is. So how do we go about it? With netcat. Netcat is such a program very similar to cat. It just transfers a stream onto the network from standard input, and it can also transfer things from the network onto the standard input. So from terminal to network, from network to terminal, whatever way you prefer to see it. And so I could connect with telnet to netcat, and the two should be able to talk, right? So first, I'll need to know what is my IP address on the internal network, one that this little virtual machine can certainly reach. By the way, the first time you try reaching any machine on your network outside of your computer, it might ask you whether this app is allowed, the AUXrunner app is allowed to reach the network. Say yes. So I'm 10.00.27. Very good. Now, if I say netcat listens to port 8888, and I say here, and maybe too little for you to see, but I just want to show it to you. telnet is connecting to 10.00.27 port 8888, then we can talk. I am writing that here in the Unix system, in the AUX system, pressing enter, and I'm getting it over here. And I can say, and I can actually reply. When I say that, it appears over here. I will go full screen in a second, then you can see it in all its beauty. Once I terminate netcat with Control C, the connection is closed by the foreign host and it's over. So theoretically, I could stream now something across netcat, right? Absolutely. To that end, let us first copy this GCC I wanted into GCC tar.gz. You'll see in a second why I'm copying it, because I want to keep it compressed for reference archival purposes. But I cannot transfer it as a GZ file, GZEL file, to the AUX system because it doesn't know how to un-GZ it. It doesn't know how to uncompress it. It's a too old system. It doesn't have that. So I need to say gzip d gcc tar.gz. And it now did decompress it and created a file called gcc.tar. But the trouble is, the gz file is gone. Because I wanted to have it compressed, I didn't work on the original, but made a copy. So now you see why I now have just a rather fat tar file, right? And it's going to get fatter still. For this is, of course, a binary file of a size of 4 megabyte. And if you transfer things over telnet streams of characters, there may be some characters, at least one I believe, that might be mistransferred. So it would be better to turn that tar file into ASCII or ASCII, so into letters that can be transferred, and you're using an absolutely ancient pair of programs, UU encode and UU decode for Unix to Unix codings of the time when UUCP, Unix to Unix copy, was the predominant Unix contacting suite of applications. And UU encode and decode still remain from that today in modern systems commonly. You say that the source file shall be GCC tar, you say that the target file shall be GCC tar, and you would like to have this all in a text file called GCC UUE. You could call that Rotkäppchen or Little Red Riding Hood if you wanted to. GCC UUE is now nothing but a very fat text file, which of course is somewhat larger than the original tar file, which you will see in a second, as it cannot use all binary values, but is constrained to ASCII characters. And for that reason, you see, it's now about a third or the half bigger. This is typical. So it swells a bit, you need to wait for a second longer, but everything should be fine. That file, however, we can absolutely transfer cat GCC UUE into the netcat listener. So the next time somebody calls on port 8888, he'll get into his face or into her face the entire UU encoded GNU C compiler. Let's do that. And it will do that for as long as the file is available. And then the transfer will terminate. Hope that you see it now better. So telnet 10.00.27 on port 888 going to gcc.uue. Enter, waiting for a moment. It happens relatively quickly, but not infinitely so. So we now finally have it transferred, and if we say lsl gcc.uue, there we have our 5 and something megabyte file. This one we're now UU decoding, and that is a little bit asymmetric, not orthogonal. It works different from UU encode. There is no piping part, you just say UU decode, and then we're going to get a tar file. So there we are having, again, our tar file, which is again somewhat smaller. Lovely. Now we're going to uncompress it. Tar x vf gcc.tar, and ta-da! You see, the GNU compiler connection is getting dumped onto our AUX system, and if we say ls, then over here we're having the GCC 263 bin thing. And if we go into it, then here you're having the script of interest, install GCC AUX, which you're just typing. And that's all there is to it. And that is how, ladies and gentlemen, you can get applications onto AUX, including more interesting ones, such that can make your life easier or your computer more useful. I actually don't have to wait for this because it is a Unix system, we know that, and we could easily have a new window and continue working from there. But as you imagine, I did not demonstrate you Pico just for nothing. In fact, I just added it into the system a couple of hours ago. Control X. Save modified buffer. No will destroy the changes. Yes. File name to write. High text. Okay. Cat. High text. And there you have it. Let's get rid of high text. So I added also Pico and I added GCC. Now we might be curious, with what languages does this come equipped? What can we do with this? There is no browser, right? There's no such thing as links or links, once with I, and X, once with I, and NKS. But we are having, nonetheless, at least a C compiler, right? Before GCC has fully installed, let's say, which CC in case it gives any link, but no, it's just bin CC. That is your K and R style C compiler. It does work, absolutely. It's just not very much you can compile with it. In fact, if you want to see what can you compile with anything at all, you could say, apropos compiler. And you're going to see it is C or Fortran. So yes, Fortran 77. You may laugh about the 77, but let's be frank, your C compiler is also very 77-ish, wouldn't you say? You may also look for an interpreter. Now, this is going to be funnier, actually, because you're going to discover that for some reason unclear, AUX actually comes with Snowball. I mean, I have been seeing Snowball in old programming books. I have never tried Snowball, but I'm charmed to see it here. I might as well learn Snowball, given that I now have it. But anyway, we are having GCC. We may ask for its version. There it is saying hi with 263. And while you are at it, you can also see that, yes, indeed, this is AUX with 3.1.1. Good, good. So now we have these two. Life is good and we continue that way. No, we don't. We want more stuff. And frankly, I, of course, went ahead and installed something which you would expect of me. I installed both BASIC and Lisp. Let's go for the simpler thing first, BW BASIC. So there is the more period correct version 1.15 that one can find online. That does work. But the problem with it is that it somehow gives you always on a new line for anything you do. This is awkward. It's not wrong. And one can, in fact, absolutely live that way, but it's strange to have the prompt above your line, right? Works perfectly. But I also wanted to try a more familiar one, and that did work. The version 2.20 where things are working just the way you would imagine, is also available. And if you want to compute the square numbers, then 20 print I times I, not be too fast. That is entirely possible, and here they are. So that made this system a lot more intuitively usable. Don't forget, in the past, the purpose of home computers was mainly to get you into a basic environment. So that's not a bad thing to have at all. But you do know, of course, that I love Lisp, and so I managed to compile GNU Common Lisp. Version 1.1 is the final one that compiles with GCC normally, with this version 2.6.3 that I'm having. Version 2.0 is compiling halfway, even with adjustments, and wasn't very satisfactory. But this one does work. And you could, of course, just do something elementary. So we are having here a functional Lisp system, and it is common Lisp. I love that. However, there's one issue that I want to show you. I want to create a recursive function that crashes the system. What it will do is it will take a number, it will print us that number on a new line, and then it will connect that number, so in a list, to a call of that same program, but the number will merely grow forever. So an infinite recursion, that certainly is not something which the system can bear. And we're having here, therefore, this crasher function that I'm going to copy, by the way, because I'll need it in a second again. So the crasher function will crash GCL. And the trouble is, it crashes it rather swiftly at slightly over 300 recursions. So 338, we are out of it. That's not terribly far, right? And if you think so, you think correctly. There is, however, another Lisp I managed to compile that required quite some touch-up of the source code because some functions weren't found, etc., etc., compile time options, and so on and so forth. But AUXLisp by Tom Almy and David Betts did not desert me. That's a version that I have been able to run in the past, as you can see last year, on way more primitive Unixes. And yes, it does compile here. And not only does it compile here, it compiles without GCC. It compiles on the native K and R CC compiler of AUX. And if you read old literature on good old-fashioned artificial intelligence, the symbolic approaches of the 1980s, you will find AUXLisp used in quite a few systems. So this is both convenient and period authentic. And while not fully Common Lisp compatible, it is still largely compatible. It doesn't have weird stuff like hash tables, but what hash tables do I imagine if my recursion is so shallow? And it will take the crasher function, but it will crash a lot farther. So if I say crasher from 0 here, we're going at well over 500, 570. That's, almost double as far as with the other one. And the lovely thing about AUXLisp is you don't have to do anything to get to top level. You just simply are back at top level. Right? If I say 1, I just get 1, that's it. Nothing further to do. It is possible with some of the other Lisps, so that you have to give options. This one just does it without too many questions. And so that pretty much concludes my demonstration. Sorry for not showing you Snowball, but I don't seem to be very good at this. There seems to be on inria.fr a version of Camel, the functional programming language that was the ancestor of OCaml. That compiles too, but I don't know how to use it. So I'm just informing you of it, but I'm not showing it. And that is how you can, you know, live in the Unix world on AUX while somehow having some peripheral Macintosh programs attached to it, as if artificially sewn together in some laboratory without too big concern for the user. There's one final disparity between the Unix world and the Macintosh world that I just want to show you. I just wonder whether I will be able to do that. And that concerns the shutdown of the system. If I go here to the Finder, yes, special would shut it down. See, there are two ways to shut down the system. I can either go here to Finder under special and say shut down, or I can try a Unix shutdown. And I can show you that even while the Unix shutdown is taking place, the Macintosh shutdown can much swifter bring the system down. So I'm saying 0 seconds, no nothing. We just straight go down. Oh my God, we go down. But I quickly switch to the Finder and I say special shutdown and close yes. Boom, we are. If you wait for the Unix thing, it will work, but it will work only after quite a while. And that's quite it, ladies and gentlemen. That concludes today's episode. I hope you enjoyed it. I hope you got a feeling for Apple's Unix from the 80s. If you have any idea how I can get Macintosh programs installed on it, please do comment. Other than that, if you haven't joined our friendly club yet, please consider doing so. Until we meet again, I wish you a wonderful time. Thank you for watching, and from me, goodbye.